Podcast number 100. Finally made it to the end of Math 3B. Find a Maclaurin series for this one, natural log of x plus 2. So we could, Maclaurin would be when you use 0. So f of 0 would be the natural log of 2, 0.693. Then take the derivative. That would be 1 over x plus 2. Substitute 0, that's going to be a half. Take the derivative of that, that would be negative 1 over x plus 2 is squared. So if you substitute in x equals 0, that's going to be negative 1 over 4. Let's see, the third derivative. So this means it's x plus 2 to the negative 2. Bring that negative 2 down in front and multiply. And then divide by, well, this would become x to the negative 3, so then you divide by that. So then we've got a 2 over an 8. And I'm just going to leave it that way so that I can see what this pattern is. And then for the fourth derivative, this would be x plus 2 to the negative 3. So if you bring that down, then we would have negative 3 times 2 times 1. Oh, it's getting to be a factorial. Then this would be to the negative 4, so rewrite that as x plus 2 to the negative 4. So this is negative, and then it's 3 factorial over, then this is going to be 2 to the 4th. So the next one would be the 4 would go down in front, and you'd get factorial, and then it's going to be 2 to the, it's going to be 2 to the 5th. So then f to the n, the nth derivative is going to be, so when this was fourth derivative, this was 3 factorial. When this was third derivative, this was 2 factorial. Okay, so that means that's n minus 1 factorial. This is a 4 and this is a 4. This is a 3 and this is a 3. Okay, so then it is 2 to the n. Then it's alternating the even ones, so this is 2 and this is 4. The even ones are the negatives, so to get it to alternate, negative 1, and then I would need it n plus 1. Because that way when n is equal to sorry, I was just noticing, wait a second, negative, positive, but I guess we could just add that in as an extra term and then come up with the pattern right here. Okay, so then we've got, it's the sum, negative 1 to the n plus 1s. So when I put a 1 in there, I should get a positive. Put a 1 in there, it becomes squared, so yes, that's positive. And then n minus 1 factorial over 2 to the n. Okay, now these are the coefficients that go in front of x to the n. And then n would go from 1 to infinity. Then we have to deal with this term. So then plus the natural log of 2. Whew. But is there another way to do this? So what if instead of doing all of that work, we take a series that we already know, like the natural log of 1 plus x is the sum negative 1 to n plus 1, and then it's x to the n over n as it goes from 1 to infinity. And this works for these values. How do you get from 1 plus x to x plus 2? So in other words, how do you get an extra plus 1 in there? Well, replace x with x plus 1. Then we would have natural log of x plus 2. Then replace this with x plus 1. And replace this with x plus 1. That seems to be quicker and easier. For what values of x will it work? So just solve for x here. So subtract 1. Oh, that's not supposed to have n equals. This is supposed to just be less than. And then this would be a negative 2, and this would be a 0, and that would be it.